Hello and welcome to Mornings with Breakfast with Unity. Both of those things are valid. Um, how are you this morning? What are we going to do? So, today we're going to be working with our little particle laser beam again. Someone had commented last time that there was a problem with our beam, and it's true. It's fixed to our camera, and it works in local space. And so it actually still kind of looks cool, but technically it's wrong because when you sweep a laser beam, you wouldn't see the same particles just following the beam, right? And you can actually kind of fix this partially by just being a bit aggressive with the particle settings, which I want to show you this first real quick. Actually, let's work on addressing particles. This is the exact same scene. I just duplicated it already, so that we can start on this episode without messing up the other ones. So we've got this particle system, and and the way we can make this move with things is we can hit world as opposed to local coordinates, which will look really bad the first time you do it because it just looks like we've got this like really loose particle beam that we're actually like pushing into the world. It looks like a little magic spell or something, which is not what you want. So you can fix that by kind of bringing the lifetime way down and bringing the velocity up a bit, just because you need them to be moving faster so that they actually make the illusion here. And so if you do something like that, and you're also going to have to really raise the particle emission, we'll put it to like 1,000. You get something that something's wrong there. Let's try a little bit more speed, and let's hit this again. Closer, and let's make it this really tight. Let's do 0.5. Point, whoops, 0.5 is what we want. 0.05. So this creates kind of the illusion of a particle beam. Now the problem is there's about 6 frames of lag, so if you just spin around, it looks really awful. So we're going to try and fix that using script. And we may tweak these values again, or even go back to the original values, but I just wanted to show you this. This is a really fast method. The scripting, I'm not sure how much this is going to take. It's going to definitely take more CPU time to do this in script. But I'm not sure how much. It will depend on the number of particles, and I would imagine it will be less mobile-friendly, certainly, than like this particle effect here. So let's take a look at this. So what we're going to do, and this is actually the first time I've played with this, so bear with me. We're going to create, we're going to call this fade particles based on distance to collider. Alright, so a long one, isn't it? But it's accurate, and I like accurate. So what we're going to do is we probably don't need a whole lot of variables here other than the distance that we want to, or the amount that we want to fade based on distance. So we will need a collider though. I can probably just pull the one that's on the same object. Let's just do that. So we're going to set this thing up with the collider. We're going to go to a particle system, and I'm going to set it up a little differently. We're going to change the emission to be... I actually still want the emission to be similar to what it is. So let's look at the shape real quick. It's cylinder, sweet. So if we look at our... Why is this in 2D mode? Alright. So we've got our little range here, and I'm actually going to make this wider again. We're going to put this back up to 0.1 so that we can make sure that this is actually working when we get to the point where it's working. And we're going to make the particles slower again, and 7.5, and actually slower again. This is kind of what we had before. But we're going to keep it in world space. And we're going to change the way these things do the fading and stuff. So right now, we fake it by using color over lifetime and just kind of have it so that they flicker in twice or once. I'm going to get rid of the twice. We're just going to do a gradient. And I actually just want it to ramp real suddenly, just so that things don't... so that we have a lot of time that they're on, and then when they go out, they actually fade out. So we'll just bring these close to... Let's put it 90%. So I'll have a 10% fade on either end. I guess I can just type it in, can't I? if I'm going to be anal about it. All right. And so the problem here, of course, is we're in world space still, so this leaves this really nasty trail. So now we will definitely know if our script is working. So what we're going to do is, in update, we're going to particle system, and yes, I'm going to still use these even though these are being phased out in the next version of Unity. Normally you'll have to use get component particle system on the new one, or you'll have to use my new system that you can get if you... Wait, why am I clicking? It's not working. Particle system. Alright, whatever. On the new version of Unity, they don't have this accessor. I've got a slightly different version you can use. If you donate on Patreon, you get access to it on the Super Repo, which is the new thing that I've introduced. The Super Repo will have a lot more stuff on it later, but right now that's all it's got on it. So, particle system dot get particles. So this gives us a list of our active particles. So we're going to do this, and we're going to do particle, I think it's particle current particles equals particle system.get particles. And I think if we just directly change these will update automatically. It's possible that might not be the case because there's also a set particles function, and we might need to use that, but we'll see. So first, what I'm going to do here is I'm just going to make sure that it works. So what I just want to do is we're just going to fade all the alphas to 0. So we shouldn't see any particles if we use this script and it works right. So what we're going to do is for each particle in current particles, we're going to take the particle dot color dot alpha equals 0.0f. This is just our test version, so we're going to see how this goes. So if we attach this to our... Oh, there's a problem. No method for get particles takes 0. What does it need? It needs get particles, and you need particle system dot particle. Wait. Oh, this works completely backwards of what I thought it did. So this returns an int for the number of particles. Okay, if we look at it, let's look at it. Let's do the full thing. Get particles. So this actually, you pass a reference to it to get the particles out. So you put in a particle right here and it fills it, and then you get back an int. And this isn't even marked as an out. So this is a little bit non-C#, but it actually does, I think it is valid. So let's see how this works. So we're going to use, so we're going to do particles, get particles, particle, wait, how could that? Oh, wait, I see. Sorry, again, just not thinking about this through. So particle, current particles, and then particle system dot get particles, current particles. Hopefully this will put the actual particles in there, and then we're going to try this. Hopefully this will work. Looks a little odd, doesn't it? Nope, still not happy. What did I do? It wants use of unassigned local variables, current particles. What does it want here? As I said, this might not actually go so well. So get the particles of this particle system. Returns the number of particles written to the input particle array. So let's try just saying this to see what happens. Maybe we have to maybe we have to give it a proper size first. Well, we have a maximum number of particles of 1,000, so let's do something fancy. Equals new particle, and I think we can specify the size here. So we can do. Does this actually work? Okay, cool. So what I'm going to do here is I'm going to put particle system. So this is automatic particle system dot max particles. Let's give that a shot. Save, and then actually we probably should do a null check here. So if particle does not equal null, then we set the color. Save. Nope, still not happy. What do we do? Get particles, particle system dot particle has some invalid arguments. Is there a difference between particle and particle system dot particle? Particle. Let's try that. Let's do particle system dot particle. And then we do the same thing here. Wonder what the other particle is. Nope, still didn't fix it. Alright, sweet. This is going real well. See, the problems happen to everyone. So, cannot implicitly convert Unity engine particle to Unity engine particle system particle. Where did I do this? Oh, yeah, I didn't do it on both sides. There are definitely two different things. So particle system dot article dot particle particle. And now let's try that. Save. Oh, come on. What's wrong? Particle does not equal null. Oh, it's probably a... Alright, so this is a struct, so we can't do that. So just, we'll just do this. File save. Cannot modify return value, a value type, return value, particle system, particle color, stored in a separate variable. Fine. Jeez. Alright. Particle system dot color, color, new color equals particle system dot color, new color dot a equals 0.0f, particle dot color equals new color. Save. Alright, one more. Cannot assign to members of particle because it is a for each iteration variable. Oh, yes, that's right. That was silly of me. So we'll do for I equals 0. Sorry, I int I equals 0. I is less than particle system dot max particles I plus plus. And then what we will do is new color equals current particles I dot color, and then current particles dot I dot color equals new color. Save. Is that enough for you? Yes, you're happy now. Did it work? Hit play. Oh yeah, I didn't attach it. I was so ready to attach it last time too. Alright, when like 6 compiles ago. So we're going to put this into our particle system, and we're going to hit play, and we should see no particles, and it totally didn't work. So I guess that means we do have to use set particles. That's silly. This is silly. Alright. Alright, so we do all that, and then we finally do particle system, set particles, and we give it the array. Is there a way to get the current particles? That would be better. Hold on. Particle system dot current count, particle count. That's what we want. That's much better. That'll save us a lot. So particle count, that's much better. And then we will give this takes 2 variables. It takes the array and the size. So we just do current particles and particle system dot particle count. Save. Let's see how this goes. Did it compile? Alright, it compiled. Does it work? Oh, it worked. They disappeared. Yay. All right. We figured it out. That's awesome. Now we have to actually do the other part. So, sorry this is going to take a little bit longer than I had expected. So this is going to be about a 20 or 25-minute episode. I apologize. In advance. Well, not really too much advance. This is short notice, but whatever. So what we want to do is attenuate the color based on the distance from the collider. So we're going to need a collider first. I'm going to put a collider on this. We're going to just put component, add, and I think I'm going to go with capsule collider. I think that's going to be the most appropriate. Oh, look, it already is really big. Really kind of bigger than we need, honestly, but that's okay. We can size that down easily. I have no idea how I decided this height, but okay, so it does go into there a little. Okay, cool, that's fine. So I'm going to do that. I'm not going to take it to the very ends because it might actually even fix our end problem if we bring it a little bit further out. And so, yeah, let's do height 2. That will be, whatever. We'll bring it down and we'll see if that actually fixes that end problem that we had before, that we currently have fixed by just kind of ignoring it. So, so what are we doing? We're going to find the closest point on the bounds of this collider. So let's do this. We're going to collider dot closest point on bound. So this is our current collider, and then we give it a position. So the position will be current particles I dot position. So I'm not sure if closest point on bounds, it probably is. Hold on, let's just look at this. Closest point on bounds. Yeah, so this is probably set up for world space, and I don't know if the particles are. Particle, what is it called? Particle dot position. I'm typing real bad this morning. Dot position unity. Wow, we actually had to specify. Usually it's popular enough. The position of the particle, that's really useful. All right, we'll assume that it's world space and just we'll see if it works first. So we're going to do closest point on bounds, current particle, and let's just print out the distance. Let's just see what we can do. D dot log. This is going to really slow things down because we're going to be just spamming this. And the distance will be current particles dot position. We need to save this. So float, no, not float. Vector 3 collider point equals collider closest point on bounds, and then we will do minus collider point, and then we take the magnitude of it. Dot magnitude. I just want to see if this is giving values that are even close to what we'd expect. So all the values should be really close to, like, it should be less than 1 on almost all of them if things are going right. And yeah, as I said, this is going to slow way down because it's creating a bunch of particles and then printing a bunch of stuff. So that looks like it's right. That looks good. I don't see anything that's like really out of the ordinary there because these are all really close to the collider, so that's good. So we're going to clear that. Now, remember, debug log is actually really slow. It's actually one of the slowest things you can do. So if you have a game that's going really slow and you're spamming a lot of debug log, that's actually the problem before anything else. So that looks good. So we're going to be using this to determine how to attenuate the amount. And we're probably going to try and make it a square magnitude version in a moment, but for right now, let's just do this. And so the closer to 0 we are, the closer to 0 we are, the more we want the alpha to be bright. And so what I'm going to use is a lerp. So we're going to do mathf.lerp. And what we're going to do is the from is going to be 0.0f, the to is going to be 1.0f, and the t is, we're going to use, instead of time, we're going to use the distance here. and that's totally accurate. That's fine for what we're doing. It's just that we're not basing this on time. We're not using this as a lerp. We're using this as just a we're using it as a lerp, but we're using it just for an instantaneous. Hey, how far away is this? Let's make this brighter. And actually, I want this the opposite. I want it between 1 and 0 because the closer to 0 we want this to be closer to 1. And let's just do this for right now and see how this goes. So that completes it, and then we put in float alpha equals math lerp, and then here we're going to set new color A to alpha. So if we hit save and hit play, okay, doesn't look like it's helping much. And that's probably because these values are never getting high enough for it to be a real thing. So let's go ahead and do that. Did that really say X-Wing? Is there actually X-Wing on good old Gangs right now? Okay, that's exciting. I shouldn't have my messages on right now, but that's cool. So I love X-Wing. Let's make it so that it lerps between 1 and 0.0 f, but we need to make this so this is magnified in some way. So we're going to do public float distance fall off multiplier to make it really confusing sounding. And we're going to set this to 1.0 f by default, but we're going to change it in the editor. So we're going to put this in here, and we're going to multiply this into the magnitude here. Now, what was I going to do? I wanted to do one more thing here. Let's go ahead and just make a square magnitude. So this will make it less directly understandable, but at the same time it's going to save us a square root operation per particle, and we're going to be just using this as a guess and check anyway. So I'm going to hit play. Yeah, this is working the way like it was. Let's just amp this up. So let's go to our fade off multiplier and make it 50 and see how that goes. Still no dice. Alright, let's make it 1,000. It's definitely doing something weird. Huh. I'm going to take us further away from the center here. No, it's... Huh. When I do this, we end up losing a bunch of particles. Okay, I think our distance calculation is not as correct as I thought it was. All right, let's assume that the position here is actually not in world space. So we're just going to go transform position plus current particles I dot position. So this should bring them to the world space. Hopefully, it might not. Okay, this is actually probably closer. Now let's choke this down a little bit. Let's bring this down to 10. No, still unhappy. 1. Yeah, that's way worse than it used to be. Huh. Sweet. This is the first absolute failure episode of Breakfast with Unity. Not absolute, but you know what I mean. It's a little disappointing. What am I doing wrong here? Wait, what? Did I not save? I didn't save. Alright. Yeah, we've definitely got some weirdness going on here. Let's try one more thing. Let's do particle. Particle. Wait, that's not where I want this. Par, particle system dot position. No, not position. Rigid body simulation space. What is simulation space? Oh, that's just sets the whether it's world space or not. Alright, let's not use the closest point on bounds. Let's use transform dot position for right now. So instead of collider point minus transform dot position. So this will look, hopefully if this works right, we'll see only particles in the center of the transform, and it looks like that's actually what it's doing. So this is actually working right, it's just we're only getting the particles. So if I pause this and we'll see, this should be like right in middle where the particles are actually showing up. And it is, and they fade out from here, right? Yes. All right. So, and if we were to like make this higher, like 10, we should see these be considerably smaller on the next frame. So if we go back into game here, I'll focus back on this. Yeah, you can see that it's just that very small area right there in the middle. So our code is working, except for the closest point on bounds is not returning what we'd expect. So what that means is, so since this part is working, that means that these particles are, does that mean that they're in world space? Yes, because if they were not, when we moved around, it would look very odd. So these are definitely in world space. And so our problem is our closest point on bounds is not actually getting spect. Why is that? Alright, so let's try this a different way. So instead of using closest point on bounds in a collider, we're going to... So the reason I was using the collider thing is because if we just do position, that's what we just did, and we only get things right in the middle, and that's because we want them to actually be as close as they can be to the center, based on just the x and y coordinates, or rather just the x and z coordinates, and not the y. If they're really far away on this axis, we still want them to be bright, right? So let's do some math instead, real quick. And sorry, this is a hugely long episode. So what we're going to do is, am I thinking about this right? So we want to figure out the relative positions. We want to eliminate the z. We can't because this is world space. We can't just eliminate the z, but we could. So if we take this calculation, right here, we're going to do vector 3, what is this called? Particle vector is what I'm going to call it. So we're going to do that. And then we're going to take our particle vector, we're going to multiply our rotation into this. So we're going to do quaternion, no, we're going to do transform dot rotation times particle vector so here we go. We're going to do vector 3. Why is this blanking me out? Unexpected symbol. Oh, because I'm not done typing here. So this will rotate it into the space that we want. Vector 3 modified vector equals transform.rotation times particle vector modified vector e dot z equals 0. I have a feeling that this is all for naught, but let's give this a shot. So then we're going to do modified vector here instead of particles.position. And yeah, I really don't think this is going to work, but let's give it a shot. So if we stop and then hit play, yeah, I definitely messed it up. Alright, so that didn't work. I just want to eliminate the Z, but I don't want to eliminate the real Z. I want to eliminate the Z after we've transformed. Because if I just reduce the Z, depending on which direction we look, it will look odd. It'll look great looking forward. Let's just do that real quick just to see the problem. Particle vector, sometimes seeing the problem helps solve the problem. Particle vector. And it's 30 minutes. Great. Particle vector. And it's morning. Or what I say, we want to see the problem. So particle vector dot z equals 0.0f. And actually, we didn't want to affect the z, right? We wanted to affect the y. Well, let's do this anyway, real quick. See what this does. And then use particle vector here as opposed to modified vector. We'll just leave that alone. Hit play. Okay, so we saw. Whoa. What caused that? That was really weird. Alright, so we saw it for just a moment, and I swear I got it to happen at some point. Here, if we can look straight up, does it work better? Or down? Yeah, okay, that's not the problem then. This is easy, and I'm totally forgetting how to do it. It's not easy. It's just. All right, I'm gonna go to the comments real quick, just in case someone is yelling at me. Hey, idiot! This is how you should do it. So view on watch page. All right. Yeah. Modified vector z does not change the world vector. It would just change the. I mean, like. So what I want to do is I want to scale. I want one of the. Actually, I really want y to be gone. Let's try that first and see if that just solves this. I don't think it will. Rotation, transfer.rotation time particle vector, hit save. Let's just see real quick. If we hit play, nope, I did something wrong. And we want modified vector again anyway. We need this to have an F, and we want modified vector, save, play. Nope, no dice. So transfer.rotation. So we're rotating it into the same coordinate system of remove local z from transform unity. Let's see if this brings up anything. Change forward. Change forward vector Unity. That's not going to be helping us. Rotation changing forward. Convert level forward into world vector. I really thought this would have worked. We are, like, this is oriented. No, it's definitely oriented oddly. Alright, so when we're using the transform rotation, it's rotating it into that space. So we rotate it into that space. So pretend we have the full particle beam there. This vector is not that vector though. This vector is the offset from the center. We're moving into that space. We should be... Alright, I'm going to call it. I apologize that we didn't actually get this. At least we got to the point where we were modifying particles. So if you've gotten stuck on it and you got to the point where you couldn't actually modify particles, we got to that point. I'm going to switch this back to the thing that was the closest thing that was working. So I'm just going to comment this stuff out. And the closest thing that we had working was just taking the particle's position minus transformed out position. And this is the one that works but is not stretched out the way we need it. So so we're going to do that. We're going to hit save. And save this, and let's just see how it looks real quick. So yeah, as you can see, the particles are only grouping in the middle, and that's what we actually want. So it's just that we want it to be the whole line and not the middle. So we're going to go ahead and save scene. Failure. Save scene again. And thank you for watching. If I have a solution for this sooner than tomorrow, I will probably post something about it. And if not, we might play with it again tomorrow, unless people have objections to that. Thank you for watching. You can email me, pushypixels@pushypixels.com. You can also tweet me @Drakfire. I love talking, so just do either of those things. And support us on Patreon, patreon.com/codeingwithunity. It would be awesome if we had your support. And if you support us for $1 or more per month, you get access to the Coding with Unity Super Repo. And the Coding with Unity Super Repo currently has very little on it. It's just easy to get component.dll. This will have a lot more on it, probably by the end of the week. But I'm going to be putting more on this over time, so this is going to have more value as time progresses. So, anyway, thank you for joining us, and you guys have a great day, and I'll catch you tomorrow with more Breakfast with Unity.